So, Mr. Eric, I think we can wait 1 or 2 minutes for the attendees to join.
Sure.
We have Anthony from Philippines team. Hi, Anthony. Ras from Indonesia. Mishin. Sulat from, Mr. Tina should join. Okay, so I think we should start now, Mr. Eric.
Sure.
Okay, good morning, everyone. Thank you for joining us for today's webinar. My name is Cao Thị Thúy Hằng. I am the marketing executive at Kirby Southeast Asia. Kirby Southeast Asia is one of the leading manufacturer in pre-engineered steel building company. We design, manufacture, supply, and erect the steel structures in Southeast Asia and in Australia. We have the factory in Dong Nai province with the annual capacity up to 50,000 metric tons per year. And we provide for all the Southeast Asia countries. And so if you want to know more about us, you can visit our website, kirbysoutheastasia.com to get more details. Okay, so now I will introduce you to our speakers for today's webinar. Okay, let me introduce you to Mr. Eric Ng. He is Malaysian and he has spent 14 years to work in the insulation industry. And now he is the regional sales manager in ROCKWOOL India Limited. So today he will share with us some useful knowledge about the insulation, including the glass roof, rock roof, and the sandwich panel. And next, I will introduce you to Mr. Pravin. He is the technical manager from Kirby Southeast Asia, and he will support us in answering the Q&A section. So our webinar will last in 30 minutes, followed by 15 minutes for the Q&A section. During the webinar, if you have any question, you can feel free to type in the chat box. Then Mr. Eric Ng and Mr. Pravin will very happy to answer all your questions. Okay, so if you follow Kirby, so you will know that we already went through 3 webinars, right? The first one is the how to deliver a 12-story high-rise structure within 120 days. And the second one, we talk about the fastener, how to choose the fastener for your steel building, for your roof and wall, I'm sorry. And the third one, most recently, last 2 months, we talk about the painting system, how to choose the right painting system for your steel buildings. So I got a lot of positive feedback from the target audience, and they asked me to continue to organize the 4th webinar. And this is also the last webinar in this year. So I very appreciate all of you here because I know this is the holiday season in other countries, and as you are very busy, some of you may take annual leave like that, but you still arrange your time to stay here and listen to us. So much appreciate from me, from our company. Okay, so now I think we can start now. So over to you, Mr. Eric.
Thank you, Ms. Hang. Thank you, Pravin. I will just share my screen, yeah?
Yeah, I will make you the host, then you can share your screen.
Right.
Okay, now you are the host, Mr. Eric.
Okay. Can you see my screen?
Yes, I can.
Okay. Good morning, everybody, participants. Good morning, Kirby. Thank you for inviting me. It's been an honor and pleasure I will reintroduce myself. My name is Eric. I work for ROCKWOOL India Private Limited. I am the regional sales manager for Southeast Asia region. I have been active in the insulation industry for the past 14 years. I spent a lot of time of my career time in ROCKWOOL International. I spent a lot of time with Kimco Isovere. I spent a majority of my time also with ROCKWOOL India, and some time with Knauf Glass Wool Insulation. As you may know, Knauf is now they have a factory in Malaysia, in the southern part of Malaysia. So they make glass wool from there. So today is not so much product training, I would say. It's maybe a little bit of discussion on what kind of insulation should be appropriate for your pre-engineered building or for your project. So I will give a very, very brief introduction. I'm by any means not an expert in the subject matter in detail. I'm happy to take questions anytime that you have. Please stop me. I will take questions regarding any of the topic that you may be interested to ask. We will first look at very briefly why we need insulation. This sounds to be a very simple and very direct question and answer. Basically, insulation is required for energy savings and thermal comfort, acoustic comfort, fire protection, and reduction of environmental footprint. Now, here we are in Southeast Asia or near the equator, where we have a lot of energy used to cool the building. The use of insulation now is becoming extremely critical for us because the cooling load is becoming one of the major factor in cost, and also a major factor for environment. And therefore, the appropriate selection of insulation is crucial in your design of building to conserve energy. And with conservation of energy, you increase your thermal comfort. And what comes with it is also, which is important, the product needs to have a fire protection properties, and it also needs to provide acoustic comfort. Okay, so here we say that in Southeast Asia, it improves heating and cooling energy bills. In Southeast Asia, it's cooling bill, but when you go to the other side of the planet, where in Europe and in America or Northern America, they need to heat the building. And for them, it's the reverse. So they need to have the heat contained within the building to reduce the use of energy bill. And of course, insulation for noise protection in hospitals, in schools, in office. Appropriate insulation should have a noise protection capability. It should also provide you with protection against fire. That means the product must be non-combustible to start off with. And the use of insulation overall in general, because of the reduction in consumption of energy, it provides you with reduction of emission of carbon. And I don't know the net carbon zero pledge of Vietnam, but in Malaysia we have a pledge of net carbon zero by 2040 for Malaysia. So, of course, one of the main criteria or main use to achieve this net carbon zero is the appropriate use of insulation. I will basically also reiterate again, an effective insulation must at least provide three main criteria or three main characteristics of an effective insulation. Number one, it must be able to insulate. The material must provide a good thermal performance. It must be fire safe. That means the product must not be combustible. It must be non-combustible. And the third characteristic of a effective insulation is it must have good acoustics. So when you select an insulation, appropriate insulation used for your project or for your building, you must look for at least a product that satisfies this minimum three criteria, right? Thermal performance, fire safe, and good acoustics. What is thermal insulation? Now, very briefly, I will not go into detail of the science of thermal insulation. In a generic building, generally a lot of heating and cooling loss is through the roof. So as far as we are concerned, for your type of project with pre-engineered building or even a commercial or a residential building, a lot of the heat comes and goes from the roof, and the cooling leaves from the roof. It's about 30%. Ventilation is about 20%. You have 16% loss through the walls, and the remaining will be from the glass, windows, the ground, and thermal bridges. And we have heat transfer, three main type of heat transfer. Heat transfer can be through conduction, convection, and radiation. Conduction means heat transfer through physical touch. So when you hold a heated metal rod, for example, you can feel the heat of the metal rod very fast. So that's a heat transfer by conduction. Heat transfer can also happen by convection. That means without touching, physical touch, you can feel the heat transfer. And there's another type of heat transfer is through radiation. Radiation means it does not need to have any medium in between the main source of heat and the point B. These are the three main types of heat transfer. And the aim of insulation is to reduce or to stop the rate of heat transfer. So heat transfer from hot to cold. So an insulation material is, the function is to reduce or to stop that heat transfer. Okay. Now, every material in the world, every product, every type of material has what we call a lambda value. A lambda value, or in many, sometimes you have, you may encounter a lambda value, a K value, thermal conductivity value. All this means the same thing. It's basically a property of the material to be able to withstand or to stop or to reduce heat transfer. So I've given here a standard list of building materials, which all of them have their own lambda value. And lambda value basically means the ability to conduct heat. And here you can see the highest lambda value, aluminum, and the lowest lambda value here is argon gas and vacuum panel. So these are lambda values that represents the material. So every material has a lambda value, and the higher the lambda value, the worse off the product in insulation. So if you choose insulation material with a high lambda value, it means that the product does not give you very good insulation property. An insulation material is characterized by its thermal conductivity value, or its ability to transfer heat, called the lambda value. The lower the lambda value, the better it is for your thermal insulation property. Okay, so when you select a range of insulation material, you want to pick out the ones that give you among the lowest lambda value. And usually lambda value is also represented in thermal resistance, with what we call the R value. R value is more of a representation of the ability for the insulation to withstand thermal heat transfer. And the formula for R value is the thickness of the insulation divided by the lambda value. So if you choose a product that has a lambda value, and the lambda value is consistent for every product, the lambda value does not change with within the product. It's a inherent property of the material. To increase R value, you need to increase the thickness of the insulation. So here, for resistance or R value, if you see in any of your specification documents, when they require R value, a higher R value means a better insulation system. So that's again reverse from the lambda value. Lambda value, the lower the lambda value, the better the insulation. The higher R value, the better the insulation. I hope I don't confuse. Everybody's okay with me so far?
Yes, it's very useful. Mr. Eric, you can start.
Okay.
Yeah. Continue.
So here I will show you an example of how R value is calculated. So I will put two examples of one of the most commonly used insulation for, I would say, for a commercial roof or a pre-engineered roof. Bubble foil or aluminum foil is commonly used in a lot of the pre-engineered roofing system. And here you can see the lambda value for bubble foil is actually lower than the lambda value for mineral wool or stone wool. But because of the thickness of the bubble foil is only 8 millimeter, and the mineral wool thickness is 50 millimeter, you will eventually translate an R value of only 0.33 for bubble foil and R value of 1.56 for mineral wool, which means the mineral wool will give you a much better R value or thermal insulation property compared to a bubble foil. This is a very quick example to demonstrate how we derive R value. Okay. So we'll quickly look at acoustic. We have talked about thermal comfort, which is a key element in an insulation material. The second element, which is very important for a selection of the correct insulation, is the insulation must provide you with some kind of acoustic insulation. We know that vibration produced by air pressure produces frequency, which then produces noise in a building or from outside the building. And depending on the type of frequency, we have a low frequency, high frequency, and medium frequency. All these frequencies generate noise. And the choice of insulation being used in your type of, in your project will be able to determine the effectiveness of absorption or the effectiveness to stop the transference of this noise into another building. So here we look at two very common characteristics of sound insulation. One is sound transmission. What is sound transmission? Sound transmission means sound that transmits in between two cavities. Okay, so here we can say sound transmission between the top floor or the bottom floor, or sound transmission in between office rooms, for example, your conference room and your discussion room, that's sound transmission. And then you may also be looking at sound transmission in between hotel rooms, for example, one room and the next room. So it's very critical to have the insulation must be able to stop the sound transmission from one cavity to the other cavity. That's one. And the other characteristic of sound insulation is sound absorption. So you also want to have your insulation to be able to absorb the frequency or the noise generated and not allow the noise to be bounced from one wall to the other wall. A very good example is when you move into a new apartment building without any furniture, without any curtains, without any type of equipment. When you start talking, you can hear your own echo back in that building. So that's what we call a very poor sound absorption, because the building does not have any capability for sound absorption. So you hear the noise bouncing back to you. So in this type of scenario, you want to also have an insulation that can control the noise bouncing back that creates echo within a cavity, and that's called sound absorption. An example of sound absorption use is in an auditorium, for example, a cinema, a classroom, a very good example. So you don't want to have too many echoes from one end to the other end, which will disrupt your presentation. So here we want to say that the acoustic comforts come from sound absorption, which provides a little bit of absorption when it comes to a noise reverberation. The the insulation must be able to absorb some of the noise being generated. Okay, so that's the end of noise or acoustics, and we will go into another important characteristic of an insulation property, which is fire. So whenever you choose your selection of insulation material, fire is an extremely important characteristic to not to miss. So the product that you choose must be able to withstand or to at least be non-combustible. Now, I'm not an expert in fire, so of course you can invite experts, fire experts, to discuss, the source of fire, the extent of fire. But basically, fire can start from inside or outside the building, as you know. And the development of fire will take about 10 minutes before the flashover. Flashover means the point where the fire starts to burn on its own. That means it's uncontrollable, already cannot control. So that's flashover. So within the 10 minutes is when the fire can develop. So if your product does not stop the development of fire within that first 10 minutes, it will go into a flashover. So once it goes into flashover, you get the third fire development, which is propagation. So you will have fire already propagating to your partitions, ventilation ducts, pipe penetration. So it becomes a very difficult to control fire already. So here you have again the 3 stages of fire. Where you have the one on the left is where you have the ignition point, where the fire will grow. This is where the fire will start. It is slow at first, and then it will grow very fast after 10 minutes, and it will go to a flashover. So between flashover and full development, this is where everything starts to burn uncontrollably. So it's very difficult to control your fire already at that point. And then you have the end of the fire, which is the cooling time. This is when all your smoke generated and all your droplets will be generated from the effects of the fire. So this is the third part will be the middle part, and the third part will become very, very difficult to control in an event of fire. So what you want to choose is ideally you want to choose an insulation material. To start off with, is an insulation material that is non-combustible in accordance to the Euroclass system. The non-combustibility is a fire rated, or not a fire rated, it's a non-combustibility rating that is in accordance to the Euroclass system. So the top 2 is the safest classification, is what we call the Euroclass A1 and A2. Which means the material, not only insulation, it can be any kind of material. It can be gypsum board, it can be your furniture. So this Euroclass A1 and A2 means the highest level of non-combustibility in accordance to the Euroclass system. So that means the product is totally non-combustible. And you have class B and C in accordance to the EN standard, the Euroclass system, where you have some level of combustibility, and then you have moderate combustibility, which the Euroclass D and E, which will generally pass a short or a small flame test in the laboratory, but most likely it will not pass the actual fire test. So that's considered Euroclass D and E. And then you have the last class, which is the worst class, which is Euroclass F, which it's considered combustible in the EN standard, the Euroclass standard. So here, as an insulation practitioner in the industry, we would always want to recommend, when you choose your insulation material, ideally you will want to choose your insulation material that falls into Euroclass A1 and A2. Don't go for anything B, C, D, E, F. It's a risk to your building, right? Or to your project. One step further to the combustibility, the harmonized Euroclass system also measures and standardizes the smoke release measurement and the hot droplet and debris release, especially for insulation. The EN standard now has also measured the smoke release definition and also hot and debris release. And they have actually very specific, they come up with very specific classification for these release. So they come up with S3, S2, and S1 to identify the amount of smoke being released when there's a fire. They've also identified the classification of D0, D1, and D2, where they measure the amount of hot droplet and debris that's being released in event of fire. Why is this important? Because when you look at an actual fire, you will notice that a lot of times people hurt or die not from the fire itself, but it's actually from the smoke inhalation. People that causes of death and hurt is from the smoke release from the burning of the building. And the other one is the hot droplet and the debris that's being released from the insulation material will start another fire within the building. So this is something that is also very important to look at when you choose your insulation, that your insulation material does not promote the release of heated droplets and begin to start another fire elsewhere in the building. Yeah. Now, an example of non-combustible material, very typically Euroclass A1 and A2, you look at mineral wool, stone wool, glass wool, usually is non-combustible. And the Euroclass B or C, usually the phenolic foams, the PE foams are usually Euroclass B or C, which means it carries a little bit of risk of combustibility or combustion. The Euroclass D or E will probably be the one that is the most risky to use for your projects, especially for your wall and your roof application. This is the product example, the XPS, the PIR, the expanded polystyrene, the cellulose fibers, membranes. A lot of them, they will say that they have added fire retardant to stop the combustibility, but it's all classified as the Euroclass D or E in the EN standard. So far this is okay?
Yeah, it's very interesting, Mr. Eric. Please continue.
And here we look at I know for Vietnam and especially for Malaysia and Singapore, we are still also very familiar with the BS standard, where we call the British standard for non-combustibility, the BS 476. So here I want to give a small comparison between the two classes, the EN standard and the British standard. So non-combustibility here in the British standard, BS 476 Part 4, is equivalent to the Euroclass A1, and then you have the limited combustibility, which is equivalent to A2, S3, D2 or better. And the various other Class O, 476 Part 6 and 7 for British standard is equivalent to B, S3, and D2. So you can give an overall feel of where, when you look at some project which requires the BS standard and in comparison to the EN standard, so you can have a general feel of where these two classes of combustibility or the ranking, where they sit in terms of non-combustibility. Okay. I will quickly say, because I'm a practitioner of insulation in the mineral wool area, and this is quite common when it comes to choosing insulation for your use. A lot of your customers will ask, are mineral fibers dangerous? Is your stone wool or rock wool dangerous? Is glass wool dangerous for health? So here I want to add that the mineral wool fiber has been classified by the IARC, which is under the WHO, as non-carcinogenic. So this mineral wool does not cause any type of health complication for use, and this has been well documented. It's a very well researched data. They have already classified the mineral fiber as a non-carcinogenic risk. And this dates back to 15-20 years ago. So it's a very well researched product. So there is no risk at all whatsoever in the use of mineral wool for any of your projects. In fact, it is so safe that if mineral wool is considered the same level of classification as caffeine, saccharin, salt, tea, just like your everyday normal products by the WHO. Some examples of use of insulation in your building, other than roof, there's also use of, I have shown here some examples of roof insulation. You can see in some cold climates, they don't use their insulation in the particular sense on the metal deck. So you can see that some of the insulation is used on the attic and also on the rafters, which is not common here in Southeast Asia. The insulation is also used a lot of in the cold climates, and also in Singapore and Malaysia in partition, in commercial partition, in ceiling application. There's also use of insulation. Here you see insulation being used also on floor, on flooring application in some cold countries where you have energy loss through the floor. And okay, this is quite common, metallic building, which is insulation is being used. HVAC is also a very common market that is insulation is actively being used for their air conducting, for heating, ducting, and also some specialty insulation used for technical insulation for industrial use, marine, also some transportation use like trains, public transportation, and even in commercial vehicles, insulation is being used for acoustic and also for thermal application purposes. And again, this is an overview of the various type of insulation that is quite commonly used. Glass wool, stone wool, EPS, XPS, PUR, and biosource. So all these are commonly used insulation material. And the function of this particular slide is to inform you that not all insulation has the one answer for your use. That means every insulation has its good and has its bad. Okay, so there won't be one perfect insulation that can solve all of your concerns. So there will always be a mix of good and bad. So you just have to choose the correct insulation based on the properties of the material and also the requirements of your project. Here is another slide to show you all kinds of commonly used insulation material, mineral wool, which is glass, stone, rigid foam, which is mostly the chemical type insulation, PUR, XPR, EPS, and some biosource type of insulation, wood fibers, cotton wool, sheep wool. Some of the new technologies being used in the market, which we have, it's quite common in Vietnam as well and Thailand, which is the use of bubble foil, aluminum foil, recycled products, and integrated insulation is also quite commonly used nowadays in the market. So there is no one perfect solution for insulation. Now, I will quickly just introduce, I'll just take 2 more minutes and we should be over. So we are now, ROCKWOOL India Private Limited is now part of the Saint-Gobain Group. Saint-Gobain is one of the leading building material manufacturer from France. And we produce a wide range of building and construction materials from glass, insulation to gypsum boards. And we are one of the leading building material solution provider in the world. They have Saint-Gobain has fully acquired ROCKWOOL India Private Limited. ROCKWOOL India has 2 factories in India, one in Silvassa and one in Hyderabad, with a total combined capacity of 50,000 tons per year. And we service the market for India, of course, is our dominant market for ROCKWOOL India. And we also supply to Middle East and also to Southeast Asia. And we service these various market segments, HVAC buildings, metallic buildings, and technical insulation, just as I've explained earlier. Our products are fully compliant to local laws and regulations. So do check with Ms. Hang, Praveet, or myself if you do require a specific requirement for your projects with regards to insulation and certifications. Very quickly, we are also FM Global approved. Our ROCKWOOL, the stone wool that's produced from India is FM Global approved. A lot of your projects in Vietnam, if you require an FM approval, so do check with us and we can help you. That's a very brief summary of the product selection for your project, insulation selection for your project. I am available to take questions, please, if you have.
Thank you, Mr. Eric, for your interesting presentation about
Thank
the
you.
insulation.
Thank you.
Okay, so we are waiting for your question. If you have any question, you can type in the chat box. Yeah, currently we don't have any question. Maybe we should wait a few minutes, Mr. Eric.
Sure. Yep.
One question from my colleague, Mr. Pras in Indonesia. You
Sure.
see the question, right?
Sorry, what is the question? Okay, on the chat box.
Yeah, it's in the chat box. I believe you can read it.
Sorry, I can't see. Hold on. Oops, I can't see the question on the chat box. I'm very sorry. Oh, sorry, there's a Q&A.
You go to Q&A. Yeah.
Okay, from Prasidya.
Yeah, Prasidya.
So it says, yeah, question further, is there a specific R value for specific building, for example, for LP? Okay, very good question, Prasidya. But it's like this, Prasidya. There is no specific R value for a requirement, R value requirement for a certain building. Generally, there is no specific R value requirement. Unfortunately, in Malaysia and in Indonesia, in Vietnam, in Thailand, the building code does not require a specific R value for commercial building use, okay, and or residential. However, in Singapore, we have a slightly different perspective. In Singapore, under the Singapore Green Building Mark, SGBC, and the Green Building Mark, there is a very minimum R value that needs to be achieved in order for you to comply with the building code for insulation. And that R value is at least 1.5. So which means you need to use at least a 50 millimeter thick insulation for all of your commercial use, insulation use for your commercial project. That means for your roof, for your wall, it must have a specific R value that has to be achieved, which is, I think it's 1.5 or 0.75. I can't remember the exact one, but there is a minimum R value. And that translates to at least a 50 millimeter thick insulation. That 50 millimeter can be any type of insulation material. It does not have to be stone. It does not have to be glass. As long as it achieves that R value requirement, so it passes the minimum standard. I know Malaysia does not have this requirement. I don't think Vietnam has this requirement as well. And I'm quite sure Indonesia does not have this requirement. It can come from the consultant. The consultant of that particular project or the architect can have this requirement to say this is the recommended requirement, but it's not a building code. That means it's not required by the government. So in Singapore, it is a law. So it's there. So you cannot, the designer or the architect cannot deviate from this minimum requirement. But anywhere else outside of Singapore, there's no such requirement. So to answer your question, Prasidya, I would say the minimum insulation use should at least be 50 millimeter thick insulation. That should give you a good benchmark, or at least a good minimum protection for insulation for your roof and also for your wall. So that usually will be about 1.5 R value.
Okay, thank you, Mr. Eric. We have one more question from Mr.
Anthony.
Anthony. Yeah, he want to compare between the ROCKWOOL and the glasswool, and which is the best between the two. I think to say which is the best is quite difficult, right? Because each kind of insulation have its own advantage and disadvantage.
Yes.
Yeah. So yeah, please clarify for Anthony.
Ms. Hang, you are correct. Both products, rock, stone wool or glass wool, has its own advantage and disadvantage. It depends on your project requirement. But what I can say is stone wool or rock wool has advantage in terms of application where you require a little bit more higher temperature rating. For example, if you have projects that require to insulate a tank that goes up to at least 300, 400, 500 degrees, those type of application, you cannot use glass wool. So you have to use rock wool or stone wool. Now, if you are only looking at a generic roof insulation or a wall insulation for a particular building application where there is no special requirement for very high temperature use, you are free to choose either or a rock or a glass wool for your project. So each project then will have their own preference. Some architect prefers stone, some architect prefers glass. It depends, but both can be used in this type of general building. I wouldn't say which one will be better. In terms of the normal use, both are equally good and they have their own advantage and disadvantage. But when you look at the higher temperature application, you have to use stone. You cannot use glass. So that's my only comment, and I hope I can be helpful to you.
Yeah, thank you, Mr. Eric.
Sure.
Okay, yeah, let's have more question. Let's try to challenge Mr. Eric.
No problem.
Okay, we have one more question, Mr.
One more
Eric.
question.
Yeah, you see it, right?
Yes, I saw it from Nivette. Hold on, what is the prompt? Mr. Eric, does ROCKWOOL or any in-house software is to identify the insulation techniques? Yes. So we have, ROCKWOOL India has a software or a thermal calculation software. It is quite a sophisticated or detailed software that we use in-house for our engineers and for our sales, technical sales practitioner. To be able to calculate actual heat transfer values, what would be the appropriate thickness to be recommended, the type of insulation to be recommended for your very specific project requirement. So yes, we do have an in-house software. The name of the software is TechCalc. You can Google the software. I think it's the limited version is available for purchase. Is this software called TechCalc, TECHCALC. So it's a software that is developed by Isover under the Saint-Gobain Insulation Group, where we use it extensively to help our customers to gain the most out of the insulation that is being used for their project. So yes, a short answer is yes, we have our own in-house software.
Mm-hmm. Okay.
But it's highly technical. I don't even know how to use it. So usually we will need all the inputs from you, and then we will pass it on to our expert, and they will calculate it for you. So yes.
I see. Eric,
you.
sorry, there is actually a follow-up question in regards to the software.
Yeah.
Usually in projects, what we see, the specification that we receive is in terms of U value.
Yes.
So for a project, we received a U value should be a minimum of 0.4. So in that case, we are using a double skin roofing. So there will be a bottom roof sheeting, insulation in the middle, and then on top we have a standing seam. So this U value is derived from this software. May I know?
No, yeah, good question, Praveen. U value, actually, you don't need the software to calculate U value. U value can be easily obtained by the inversion of the R value.
Right.
Okay, I think you know, right?
Mm-hmm.
So you get an R value for your system. So you have your double skin, right?
Mm-hmm.
So you have your double skin metal, you get your K value for your metal, you get your K value for your insulation, and then your K value for your bottom metal. And you also have the K value also for the air on top and air at the bottom.
Mm-hmm.
And then you get all the K value, and you get your total R value.
Some of them
you inverse that total R value, that should give you your U value, right?
Mm-hmm.
So in Singapore, I think the minimum U value, you cannot go below 0. Like you say, I think 0.4, 0.3, I can't remember.
Right.
Here's a tip for you, Praveen.
Mm-hmm.
As long as you choose an insulation that has 50 millimeter thick in your roof system, whether is it roof or wall,
Mm-hmm.
it will pass the minimum U value requirement for Singapore.
I see.
It has to be 50 millimeter insulation. Anything below 50 millimeter, you will not pass that minimum U value.
Nice.
Yeah.
Okay.
So I mean, you can try, and it's very simple to calculate. I can help you offline. Just call me. I can show you how it's done. So it's something that is simple. You can check on your own.
I see.
So it's pretty. It's quite interesting for you to actually test it out. So I think Singapore calls for 0.4. Yeah, you're right, 0.4. So anything that you choose that is 50 millimeter thick insulation, it will pass. Don't go below 50 millimeter.
Understood.
Yeah.
Thank you, Mr. Eric. It's Anthony Van Jogan again.
Sure.
This time he asked about how to
Yeah.
choose the sound insulation for the air-conditioned music studio. Maybe it's a karaoke shop, I guess. So he used the ROCKWOOL in the air-conditioned music studio project. Did he get it right? Please advise.
It depends how you use the ROCKWOOL. A lot of the use of insulation for acoustic purposes in like, for example, in your case will be for your project. I don't know, it's for a music studio. So acoustic is a very, very broad subject. It's also very deep and very broad. And I'm not an acoustic engineer. And you require an acoustic engineer to actually simulate what kind of acoustic insulation that is appropriate for your project, right? The reason I said that is because not one project for acoustic is the same. Every project for acoustic application, whether is it a music studio, cinema, every project is different. Here you say it's a enclosed air conditioning music studio. So music studio also, it also depends what kind of music studio. Is a music studio with traditional music equipment, or you're looking at electric guitar, or you're looking at just normal music or singing. So all these have variation of frequencies and pitch and various decibel that's being produced. You need an acoustic engineer to study these frequency and the low frequency decibel to be able to understand and also select the actual and appropriate insulation used for your project. Now, ROCKWOOL is correct to use because it's non-combustible. It helps you with your acoustic. But sometimes, due to the variations of the music source or the type of music being generated in your room, you may choose a different types of ROCKWOOL system. Sometimes it can be 50 millimeter, can be 100 millimeter thick, can be 75 millimeter thick. So which type of thickness being selected and what type of facing being used and the system being selected very much depends on the actual music studio requirement, which you will require an acoustic engineer or acoustic consultant to be able to assist you.
Okay, thank you, Mr. Eric. Okay, do you have any more questions? We're still waiting for your question. Any question about Kirby? Praveen is waiting for you.
No, it's Eric, I think we missed one question on the top.
Oh, sorry.
So do we have a 2-hour fire rated insulation? As I see in the presentation, 60 minutes is the longest. In case of 2 hours, what is the main material?
Oh, from Anthony. Sorry, I missed Anthony. Sorry, I missed your question. Okay. Your question, Anthony, is a fire rated insulation. Now, what I have presented earlier is not a fire rating product. What I have presented earlier is a fire reaction to fire product that has is non-combustible when it comes to reaction to fire. That means when there is a fire source, the product does not react to fire, so it's non-combustible. Your question is a little bit different. Your question is asking for a fire-rated insulation. Fire-rated insulation is slightly different. Actually, it's very different. Fire-rated insulation means when there's already a full fire developing, how long your fire rating of your system, how long can this system stand? And you are asking for 2 hours. So this system must be able to withstand 2-hour fire rating. Just the stone wool or the insulation itself is non-combustible. Okay, just the stone wool, the insulation itself is non-combustible. But when you're asking for 2-hour fire rated insulation, it has to correlate with the entire system. That means it has to come with the metal sheet. It has to come with the gypsum board. It has to come with the whatever fastener or the channel that comes with it. Because fire-rated insulation system is a system on its own. It's not only dependent on the insulation. So your question is a question which I am not able to answer you because it also depends on the other components that is being used together with the insulation. What I can tell you, the insulation itself, it has to be non-combustible. So you have to then choose the appropriate system to enclose the insulation to make it a 2-hour fire rating system.
Okay, thank you, Mr. Eric. So if you have any suggestion for our next topic for the next webinar, you can also type in the Q&A. So we can, based on your suggestion, and do the next webinar with your design topic. Yes. Okay, so any more questions from you? Seems that we don't have any more questions, Mr. Eric. Okay, so
tough questions. You guys are a tough crowd. Today you make my salary worse. Yeah, it's a lot of work today.
Yeah. Okay, so if you want to, if you have demand for installation, you just come to Eric and
Sure.
for ROCKWOOL India Limited. But if you have any demand for the pre-engineered steel building, just contact with us. Kirby Southeast Asia is very willing to give you a solution. Yes, with the best price and excellent customer service. Yeah. Okay, so I think we can end the webinar here, Mr. Eric.
Thank you, Kirby.
Yeah.
Thank you, Ms. Hang. Thank you, Praveen. Thank you, everybody, to participate. Any questions, please feel free to contact Ms. Hang or myself directly. We'll be more than happy to assist you. Thank you so much for your time.
Yeah, if you have any more questions after this, you can feel free to
Yes.
send email to me or
Yes.
Mr. Eric to have more insight about the insulation.
Sure.
Yeah. Thank you, Mr. Eric,
Thank you.
for
Thank you. Thank you.
very useful presentation. Thank you, Praveen,
Thank you.
for
Thank you.
joining with us. Thank you, everyone.
Thank you.
Goodbye.
Thank
See
you.
you next
Goodbye.
time.
Thank you. Bye-bye.